Disclaimer. The information provided to you in this video course is for educational work only. It teaches you how to work with Linux and some security tools from the information technology. The author is not responsible for the way you use this information. The information provided to you has an educational objective, to impart knowledge to everybody who is interested in Linux. Persons who want to use the shown knowledge to harm other people are unwanted, and it is forbidden to them to watch this video course. At first, I want to give you a short overview about this course. We start with the basics of Linux, and then we will learn how to use files and directories. After we are able to handle the Linux basic commands, it is time to go deeper into the system and network areas of Linux. Then you will learn how to use the shell and shell scripts. After that, we will take a look at the toolkits of Backtrack 5 and also on the configuration files of the Linux system. Last of all, we will take a look at daemons and how they work. I hope you will enjoy this video course and learn something useful. Welcome to part 4 of this video course about Linux. In this part of the course you will learn the basics you need to know if you want to work with the shell and shell scripts. I will not explain every single detail, but if you know the basics, you are able to work it out by yourself. In nearly every case you can use the help commands and manual pages I showed you in the course part 1. Good. But now let's turn back to our main topic, the shell. What is a shell, you may ask yourself now? A shell is an user interface, but it is also a program that the user can use. The shell we use until now in this video course was the bash, the born-again shell. There also exist many other shells like the C shell, and the TC shell, the PDK shell, the Z shell, the Korn shell, and so on, but I will give you in this part of the course only explanations about the bash, because this is the most common and used shell under Linux. The bash shell is not a part of the operating system, and it can be replaced by an entry in the passwd configuration file in the system directory, etc. To see what shell we use at the moment, as user root, we type in our shell interpreter the command /etc/passwd pipe grep, followed by the username root. This gives us the output of one line from the file passwd. At the end of the line we see the bash command. The bash command is the application that interprets commands when we type them into the bash on our screen. If you type now just etc passwd, then you will get to see the whole lines of the passwd configuration file, but this is a topic you will learn in part 6 of this video course, when we will talk about configuration files. Okay, and now back to our shell topic. To get more knowledge of the bash shell, type man bash, and then read the manual pages. This is great stuff. In the manual pages you find nearly everything that you need to know about the bash, and the shell scripting topic you will see in this part of the course. I highly recommend you to read that all, if you want to know all about your Linux system. There are many interesting informations, and also many examples, but I tell you this just by the way. The shell is like a programming language. It has its own commands, like set, if, case, or exit. You could place these commands of the shell into a file, and after you start the file that contains this command, the bash, or the Korn shell, or any other shell will interpret these commands and cause some actions on your Linux system. You also can declare variables, and get a return value back from your script. Every command you have learned until now can be used in a shell script. You can schedule your scripts in the foreground or in the background. You can use pipes, you can use wildcards, and you also can declare and define variables in your shell scripts. Your shell script could do everything on the system what the user can do, who runs this shell script. All permissions the user has on the system, the shell script has them too. Okay, enough of talking, let's see some examples. At first we will create some files and directories. Open the terminal window now, to type some commands into it. Type make directory space, D1, space, D2, space, D3, space, D4, space, D5, and hit enter. With that command we have created now 5 folders. To see the result type in the list command, type ls. Do you see the output? Good. Now we will need also some files to create very fast some files. We will use the touch command. Type into your shell, touch, space, F1, space, F2, space, F3, space, F4, space, F5, and hit enter. That will create 5 files. To see the result, type once again ls. Do you see the output? Good. The first example I will show you is the use of the question mark. The question mark replaces on character, except blanks and dots. For example, if a hidden file begins with a dot, the question mark cannot replace that sign on the shell. I will show you now on the shell how this works, so clear the screen with the clear command. Now type ls minus the option A, to see all files and directories, not only the visible but also the hidden files. Do you see the output? Crazy. Every file or directory that begins with a dot is hidden in Linux. The reason for that is quite simple. In the most cases the files are configuration files or directories, but this is another topic, so let's go back to our bash window, and type now ls, space, d, followed by the question mark. Now you see that everything that starts with D and contains 2 characters is now on the screen. Now type ls, space, f, followed by the question mark. This shows you now the files that begin with lowercase f. In the next example you will learn how to list all files and directories which end with number 4, so type now ls, space, question mark, followed by 4, and hit enter. Do you see the output? This command shows you one directory that ends with the number 4, and also one file that ends with the number 4. Both consists of 2 characters, and the question mark can replace every other character, except blanks and dots at the beginning. Now you learned how to use the question mark placeholder. Congratulations! Now we will take a look at the star wildcard or star placeholder. This works nearly exactly like the question mark wildcard, but the star stands for known, exactly one, or also for more than only one character in front of an item, in the middle, or at the end of an item. That sounds complicated, but it is very simple. We create now 2 more files. Type in your shell, clear to clear the screen. Next you type ls, to list all items in the current directory. Now you type, touch, space, f, 123, space, f, 456, and hit enter. In the next step you use the list command once again to see what files you have created, so type ls, and hit enter. You see now the 2 files, which consists of 4 characters, file 123 and the file 456, good. Now type once again clear to clear the screen. The next command you type is ls, space, and 2 question marks. After you hit enter, the bash shows you all files and directory that consists of 2 symbols. Now let's try the same with the star wildcard. Type into your terminal window, ls, space, and then 2 star symbols. What do you see now on your screen? Exactly. You see that all items that are visible and can be listed with the ls command are now on the screen. You will see it better if you type only ls, space, question mark. The result is that no file or directory can be shown to you. Now type ls, space, star wildcard, and you see all visible items. Now type ls, space, 4 times question mark. After you hit enter you see only the files that consists of 4 characters. I hope you could understand the difference now. Now one more example with square bracket, so let's go. Open the terminal window, type in ls, to see the files and directories we have created for this session. Now type ls, space, lowercase d, left square bracket opening, 2-4, right square bracket closing, and hit enter. This shows you everything that begins with lowercase d, and is followed by the numbers 2 till 4. The directories D1 and D5 are not displayed. Good. Now we want exactly the contrary. This can be achieved through the exclamation mark in the same command, so let's type ls, space, lowercase d, left square bracket opening, exclamation mark, 2-4, right square bracket closing, and hit enter. Do you see the output? The exclamation mark negates the command. This is great stuff. You also have the possibility to type in more than one command on the terminal line. To achieve this goal, you separate every command by a semicolon. Let's see an example. Type in cal, space, free, space 1314, semicolon, echo, semicolon, echo Monday, semicolon, cal, space, free, space, 1314, pipe, grep, 18, OK and very good. Now you have seen how to use more than one command on one terminal line. Good. In the next example you will learn how to use subshells. To achieve this goal we will use the round brackets. Open the terminal window, type in left round bracket, cd, for the change directory command, space, /bin, semicolon, pwd, right round bracket, and hit enter. Do you see the output? Take a look at the prompt. You are still in your home directory. That is because we used a subshell. To see the difference we will type the same command, but without round brackets, which open up subshells, so type in the terminal window, cd, space, /bin, semicolon, pwd, and hit enter. Do you see the output? Take a look at the prompt. You are no longer in your home directory, but instead of that in the /bin directory. Good, now you have learned how to use subshells. This is a very powerful function of the bash. In shell scripts you will need often. Good. Hit now Ctrl+D, or type exit to close the terminal window now. OK. You know now a few commands more on the bash shell. It is time to write our first shell script. Therefore you need a text editor. The most common editors for the shell are VI, Vim, Emacs, and Nano. For our first shell script we will use the Nano editor, because I think that it is easy to use, beginners can handle it very quickly, and everybody else can use VI, or Emacs. Feel free to use your favorite, but I will show you now the examples in the Nano editor. So let's get it started with Nano. Open a new terminal window, type in nano, space script, .sh, and hit enter. Next type in make directory, space script folder, semicolon, then hit enter for a line break. Now type cd, space script folder, semicolon, then you hit enter for a line break, and type in the next line, Dutch, space, file.txt, semicolon, next you hit enter for a line break, and type cd, space, dollar, uppercase home, semicolon, good. That was everything we need to do. Now we will save the file by pressing Ctrl+O, and then hit enter without changing the name of the file. After that we hit Ctrl+X, to exit. Now we should be back on the shell. To see if the file has been created correctly, we type ls. Do you see the output? OK. But the file cannot be executed. To achieve this goal we need to make the file executable. We can do this by the command chmod. Type in chmod 100 script.sh and hit enter. Now take a look with ls-l, you see that the file is executable now, good. To execute the file we type in at the prompt, sh, space, script.sh, and hit enter. Now we type ls to control the content of our current directory, and we see a directory named script folder, great stuff. But what is inside this folder? Type ls, space, script folder and hit enter. You should see now a file.txt. Congratulations! This was now maybe your first shell script. You could write many other scripts in this way. Everything you need to do is to read the manual pages of the bash completely. That is the only advice I could give you. The last example for this part of the video course is another shell script. Open a new terminal window, type in cat, redirection symbol, delete.sh, then hit enter. Now type in the first line, echo, quotation marks, deleting, quotation marks, semicolon, and hit enter. In the second line you write rm, minus, uppercase R, space, script folder. Now you press Ctrl+D, and after you press that key combination, you should be back on the prompt. Type ls minus the option L, to see the attributes for the script file, delete.sh. Now we change the attributes, so type chmod 100 delete.sh, and hit enter. Type ls-l to see the attributes of the file. Now you should have the permission to execute this file. And that is exactly what we will do now by another way to execute executable files. Type into your shell /delete.sh and hit enter. Now type ls and the script folder with its content should be disappeared. Now we type /script.sh and look again at the items of our current directory with the command ls. The directory script folder has been created now, and one more time, type /delete.sh and hit enter. Type ls, and the directory script folder will be removed with all its content. Thank you for watching this part of the video course. I hope you learned now the basics for the bash shell, and understand how shell scripts work. There are a lot of more commands, but because of the time factor, I could give you only a short overview about the Linux basics for this topic. I am glad if you watch the next parts of this video course. In part 5, The main topic are the toolkits of Backtrack 5. In Part 6 we will take a look at the Linux config files, and in Part 7 we will work with daemons.
Let the beat control you.